Welcome to Electronics with Mr. Estabrooks. Today I'm going to demonstrate how to display the capacitor charge-discharge cycle with a 4-channel oscilloscope in multisim. So I have a simple circuit here with a resistor capacitor in series with a 5-volt DC power supply and an SPDT single pole double throw switch. So right now notice I do have a parallel loop pin here, but the switch actually makes it 2 individual series circuits, because you'll notice with the switch in this setting we have a complete series circuit with the 5-volt power supply, the resistor, 1K resistor, and the 50 microfarad capacitor. Then if I switch the move the switch down to this setting, now we have a second series circuit with just the capacitor and the resistor in series. So it may look like a parallel circuit, but it's actually 2 series circuits with this switch selecting between them. So what I'm going to show you is how this circuit behaves to charge and discharge the capacitor, and we're going to do that using the virtual 4-channel oscilloscope. Now the oscilloscope can be found in your toolbar over here on the right side of the screen, and if you don't have this toolbar here, you can turn it on and off from the view menu and select toolbars and instruments. So if you notice if I check that off, it goes away. View, toolbars, instruments, and there are a couple different oscilloscopes here, but I prefer using the 4-channel scope because you can connect up to 4 inputs to it. So the 2 scopes are the oscilloscope here and the 4-channel scope here. You click that, drop it in, wire it in, and double click on it to open up the actual scope display. Now this is the trace that was on there the last time I ran the simulation. If we turn on the simulation, you'll see this red line tracing out 0 volts. That's because right now the 5-volt DC power supply is not in the loop, so there's no voltage. But if I turn the switch on, which I can do by clicking on it or pressing the space key, now notice the classic stereotypical charge cycle. And then the capacitor is charging up to 5 volts because that's the voltage source. Current stops flowing when the charge on the capacitor reaches 5 volts. Then when I switch this down, what's going to happen is the capacitor is going to discharge through the resistor because we have ground here and we have a series circuit, and you'll notice the classic discharge curve. So that's what a capacitor discharge curve looks like. And here we begin another charge cycle when I flip the switch. Discharge, charge. Now the time it takes for the capacitor charge and discharge is dependent upon 2 things: the value of the resistor and the value of the capacitor. And there's a constant known as tau, or the time constant, which is basically the resistance times the capacitance. Tau, or the time constant, equals RC, resistance times capacitance. And it takes just about 5 time constants, or 5 tau, for the capacitor to be considered fully charged or fully discharged. So you can do the math pretty easily. Remember, 1 kilo ohm is 1,000 ohms, and 50 microfarads is 50 times 10 to the negative 6th farads. You have to use those actual numbers. Don't forget to convert the micro and the kilo to their equivalencies.